Now, in this session, we will study about mass and weight, or what is the difference between mass and weight. So, let us write it in a column, right? So, if you are asked to differentiate, we usually write it in column, right? So, what is the definition of weight and what is the definition of mass? We have studied in your standard 6 what is mass. Mass is the quantity of matter contained in a body. So you can write mass is the quantity of matter. So I'll just use short form. Quantity of matter contained in a body. Quantity of matter contained in a body. Then, what is weight? Weight is the force with which earth attracts a body. So, what is weight? Weight is the force with which earth attracts a body. It is the force by which earth pulls a body towards the center of the earth. Earth attracts a body. So, usually, in the second point, we depict mass as m. We depict mass as m. Mass is treated as m. We will write it as m. But what is weight? We know that it is the force with which earth attracts a particular body. So what will be that? Force is equal to mass into acceleration. So acceleration here will be, when it is under free fall or under the influence of gravity, it will be g. So the weight of a body is the force, that is force is equal to weight. That will be equal to mass into acceleration. So look, what is the difference between mass and weight? Mass is m and weight is m into g. For example, 10 kilogram mass is given to you. What is its weight, children? It is 10 into 9.8. That is 9.8 into 10. That is 98 Newton. So now we will deal with the unit. We are actually writing the difference, right? So what is the unit of mass? Standard unit of mass is kilogram. But what is the unit of weight, children? Weight is, what is it? Force. It is force. So the unit is Newton. So the last point comes to you. Mass is a constant, right? If we are having a 10 kilogram on earth, when we move to moon also, the mass remains the same. So the mass can be treated as a constant. Mass is a constant always. If it is the earth, in Jupiter, in moon, in anywhere in universe, mass is a constant. But think about whether weight is a constant or not. We have already studied that this g depends upon the mass of the planet, radius, etc. So when we compare earth and moon, we can just take a comparison. Is this the same? The mass of the earth and the mass of the moon are the same? No. So exactly, this g will be different on earth and different on moon. So the weight of a body on earth will be different from weight of the body on moon or weight of the body on any other planet. So what we can write about weight? Weight of a body, weight changes from place to place. So let me just ask you, what is the weight of a body? Compare between the weight of a body at the pole and the equator. We know that in the equator, g is less, right? And at the pole, acceleration due to gravity is more. So where will be the weight of a body more? The weight of a body will be more at the poles. There can be a question for comparison of this mass and weight. A 2 kilogram block of gold was moved from the equator to the pole. Just think about it. A 2 kilogram block of gold is moved from pole, equator to pole. What happens to its mass and weight? What happens to its mass? Nothing happens to its mass. Mass remains the same. But what happens to the weight? We know that g at the pole, this g factor is more at the pole since the radius is less. So, weight of the 2 kilogram of mass of gold increases. That is, the weight at the pole is greater than weight at the equator. This type of application level question can also be asked. That's all for this session. Thank you, children.